Uh, Hello students, in our regular class, we discussed about introduction to statistics, like where to use the statistics and all. After that, we discussed about definition of statistics. After that, we discussed about definition of statistics. Later, we discussed about sorry, we discussed about what do mean by biostatistics as well as medical statistics. Right. So, okay. First, we discussed about biostatistics. Then we discussed about what do you mean by medical statistics. Then we discussed about some basic definitions such as population. I mean, what do you mean by population in that finite population and infinite population. Later, we discussed about some examples related to population. Then we discussed about sample and examples of samples. Then we entered into the basic definition concept of variable. What do you mean by variable and what are the different types of variables here? We have quantitative variable, qualitative variable. In quantitative variable, discrete as well as continuous. In qualitative, we discussed about ordinal and norm. So in detail, we discussed about what do you mean by quantitative variable, what do you mean by qualitative variable. In that, in quantitative variable, what do you mean by discrete variable with examples as well as continuous variable with examples. Then in qualitative variable, we discussed about what do you mean by qualitative variable and how to denote it, nominal data as well as ordinal data. And here, okay, next is we discussed about data. What do you mean by data? What do you mean by primary data as well as what do you mean by secondary data? Then followed by methods of collecting primary data. Then in that methods of collecting primary data, we have a direct personal interview method, indirect personal interview method, then information through correspondence. Then fourth one is mailed questionnaire method, and the fifth one is schedules sent to enumerators. We discussed about these in the concept of methods of collecting primary data. After that, we discussed about methods of collecting secondary data with examples. We have only two methods to collect secondary data. One is primary source, sorry. One is published source and one more is unpublished source. So we discussed a few examples related to published as well as unpublished source. Then we discussed about the differences between primary as well as secondary data. We have so many differences, but for our study, for our premises, these are the uh, four differences are sufficient, and these are the important uh, differences between primary data as well as secondary data. Then we have discussed about that applications and uses of biostatistics as a science. It means that in science, uh, what is the application? I mean, what are the uses of biostatistics? We have so many important areas such as psychology and anatomy, then pharmacology, in medicine, in community medicine and public health. We have some day-to-day life applications. Then we discussed about important concept, that is classification of data. Here we discussed about what do you mean by classification of data. That is what the grouping of data according to their common characteristics. Then we discussed about types of uh, classification, such as geographical classification. Means what? It's depending upon the various areas. Geographical classification. Then chronological classification. It means that it's related to uh, different time periods, then qualitative classification as well as quantitative classification. With example, already these concepts are discussed in our regular classes. Then we discussed about tabulation. Tabulation is nothing but presentation of data in the form of rows and columns. Then one of the greatest tool representing the data in the form of table is frequency distribution. In frequency distribution, we discussed about categorical frequency distribution. It means that a table containing variables Categorical frequency distribution means what? A table containing qualitative variables, right? So it is helpful to represent only qualitative variables. After that, steps. So we have three steps to represent the data. I mean, qualitative data. Then we discussed one example related to classification of the, sorry, one example related to classification of the data. That is, in a clinical trial, it was observed that opinion given by 40 patients. So these are qualitative data. We need to represent in systematic manner. So we represented here like this. This is also covered in our regular class. Then we have second one, that is second type of frequency distribution, that is frequency, a discrete frequency distribution. It means that a table containing quantitative variables and frequencies along with their tally marks. So here also we have three steps. These steps are already discussed in our regular classes, and we solved one example also in our regular classes. This is what example we solved. Then in this class, I will start with continuous frequency distribution, right? So up to here, whatever I um, I revised whatever the concepts we discuss in our regular classes, I mean in offline classes. So the next concept is continuous frequency distribution. The next concept is continuous frequency distribution. Again, as usual here, first we'll discuss about the uh, definition of continuous frequency distribution, as well as some basic definitions again we need to study. Basic definitions we need to study related to this continuous frequency distribution. After that, we have types of class intervals. I mean, this is the extension topic of the continuous frequency, only types of class intervals. Then we have uh, steps steps to create continuous frequency distribution. Then later, we need to discuss the examples for continuous frequency distribution. So in this concept, in continuous frequency distribution, we need to discuss these uh, parameters. So now we'll discuss one by one. The first one, that is continuous frequency distribution, right? Frequency distribution means obviously we know that presenting the data in the form of tables. Tables means what? Rows as well as columns. So now continuous frequency distribution, it is a table containing class intervals and frequencies along with their tally marks, right? So a table containing class intervals. These are nothing but class intervals. These are nothing but class intervals, and this is nothing but tally mark, and this is nothing but frequency. Right. So a table containing class intervals and frequencies along with their tally mark. So this is called continuous frequency distribution. To look continuous frequency distribution, exactly it is whatever I drawn here or whatever I represented here. Now we'll discuss some basic definitions related to continuous frequency distribution. If you observe in the definition of continuous frequency distribution, I use the word class interval. I used the word class interval. So now we'll discuss about what do we mean by class interval, likewise what do we mean by class frequency, what is the midpoint of the class interval, what is the size of the class interval. Likewise, we have 5 basic definitions we need to discuss now. So here, first one, first definition, that is class interval. Right? So class interval means what? The large number of data can be classified into various small groups. Those groups are called class intervals. See here, for this example, I consider pulse rate of the human body, right? So here, when we observe the data, 68 to minimum here, 68 to 78, we consider, and in between 68 to 78, Total, there are 47 patients are there. Is it clear? 68 to 78. Total, there are 47 patients are there, right? So here, how to divide these 47 patients into small groups according to their pulse rate. For that, we can use continuous frequency distribution. In continuous frequency distribution, we have first one, that is class network. Whenever the large number or whenever you have huge data, this huge data is classified into small groups, such as, so 68 to 78, I divided 68 to 70. It is a one small group. Is it clear? 68 to 70. I did first group. This is our first group. And I did second group 70 to 72. Third group 72 to 74. Means what? I'm dividing the big data into small groups. Those groups are called class intervals. Say, for example, in this table, 68 to 70. 68 to 70 is the first class interval. 70 to 72 means this one. 70 to 72, this is second class interval. 72 to 74, this is third class interval. Then 74 to 76, this is fourth class interval. Then 76 to 78, this is what? Fifth class interval. It means that 68 to 78, I divided the entire data into small groups. Those small groups are called class intervals. The various small groups are called class intervals. I hope this definition is clear about the class interval. Next is next definition, that is class frequency. Next definition is class frequency. So very easy definition. Class frequency is nothing but the frequency corresponding to class interval is called class frequency, right? The frequency corresponding to class interval is called class frequency. Means what? In the previous example, sorry, not the previous example, in this example, whatever we discussed now, in this example, see here, in this example, there are two patients are admitted. Two patients have pulse rate 68 to 70, right? So next, five patients have pulse rate 70 to 72, right? So 2 is the class frequency of this class interval, first class interval. 5 is the class frequency of the second class interval. 15 is the class frequency of the next class interval. 14 is the class frequency of the fourth class interval. Then 11 is the class frequency of the last class interval. It means that class frequency is nothing but the frequency corresponding to class intervals. The frequency is corresponding to class. It means what? Frequency is with respect to their class intervals. So those are called class frequencies. So here 2 is the class frequency for 68 to 70. 5 is the class frequency for 72. Then 15 is the class frequency for 72 to 74. 14 is the class frequency for 74 to 76. Then 11 is the class frequency for 76 to 78. Clear? So this is what the concept of class frequency. The next one, next definition, that is class limit, right? Class limit is nothing but the two boundaries, the two boundaries of class intervals. See here, the two boundaries. Two boundaries means what? 68 to 70. See here, we have 68, 69, and 70 in between 68 to 79. The two boundaries of class intervals are called class frequency, class limits. Here 68 to 70. 68 and 70 are limits for the first class interval. Those are called class limits. For second class interval, 70 to 72. Then 70 is the lower limit, 72 is the upper limit. Next, 72 is lower limit, 74 is upper limit. So likewise, uh, class limit is nothing but the two boundaries of class intervals. The two boundaries of classes are known as class limits. In other words, class limits are highest and lowest values can be included in the class. So now here some note point. lowest value of class in lowest value is called lower class limit, highest value is called upper class limit. See here, in that table, we have first one 68 to 70, next one 70 to 72, next one 72 to 74, 74 to 76. Likewise, we have 76 to 78, last one. See here. Okay. So here, what I told, the two boundaries, right, of a class interval are called class limit. Then here, lower value is called lower limit. Lower value means in 68 and 70, which is lower one? 68 and 70. Lower is 68. So 68 is lower class limit, and 70 is the upper class limit for only for first class interval. Is it clear? Then for second class interval, what I wrote second class interval, that is 72, 72. Here 70 is the lower limit, 72 is upper limit. For third one, 72 to 74, this is lower limit, this is upper limit. For fourth one, 74 to 76, this is lower limit, this is upper limit. And then for 76 to 78, this is upper limit and this is lower limit. Right. So likewise, this is the concept of class limit. The next one we have next basic definition, that is midpoint of the class or midpoint of the class interval. See, midpoint of the class interval is nothing but exactly middle value of the class interval. Exactly middle value of the class interval. See here, 68 to 70. This is the first class interval. What is the middle value? Middle value is the 69. Middle value is 69. How we got? We got by adding upper limit, this upper limit and lower limit and divided by 2. So 138 divided by 2, that is 69. So in this way, we can get midpoint of the class interval or midpoint of the class. Right? So midpoint is nothing but the value which lies between in between the class interval, exactly the middle one. That is the concept of midpoint of the class interval. Next is size of the class interval. The next definition, that is size of the class interval or width of the class interval. Width of the class interval is nothing but the difference between width of the class interval is nothing but the difference between upper limit and lower limit. For the first one, 68 to 70, this is the first class interval. The difference between what? Upper limit minus lower limit. The answer is 2. This is what how we got. Then for the next one, that is 70 to 72. 72 upper limit minus lower limit 70. The answer is this is also 2. For next one, 72 to 74. Upper limit 74 minus 72. The answer is 2. Right. So likewise, we can calculate the size of the class interval by using the formula upper limit minus lower limit. So here we end with all the basic definitions of class interval. Sorry, basic definition of continuous frequency distribution. First one is class interval. We studied that is what making these small groups. Second one, that is class frequency. The third one, a class limit. The fourth one, midpoint of the class interval, and the fifth one, size of the class interval. Right. So here these are the basic uh, definitions. So these are the basic definitions along with the definition of continuous frequency distribution, right? So this is what the entire concept of continuous frequency distribution along with the basic definitions.